Okay, let's see if it works now. I think all I had to do was just add an audio source that takes the sound from the mic, because I'm using the OBS Studio, and by default it can take the sound from the software running on the computer, from the desktop, but it wasn't actually capturing the microphone, so there was no sound from the mic. Let's see if I get any sound now, because
Awesome.
I'm using the OBS
Cool.
Studio. Awesome. So we have sound. Okay, on this live stream, I'm going to be assembling a few boards. So this is one of them. Let me just, I'm going to just bring up the OBS Studio so I can see what I'm showing in the camera. So this is a long-range modem that I've designed. This PCB got manufactured during like the summer, like 6 months ago. I basically didn't have time to assemble these prototypes. I don't have really good memory of exactly what I put on there, and if I have all of the components here in this pile of plastic bags that I ordered from Mauser. This is not even supposed to be here. We'll see. It should be enough components for 4 boards. I have another PCB here, and I have also 2 other PCBs. Let's see if I can find them. The other PCBs are for a prototype of a sonar sensor. So I'm just gonna see if I can find them. Yeah, here they are. I'm just gonna put them on the camera. So this is a prototype for a sonar sensor that is able to communicate over CAN. It's gonna have an STM32 over there, and it has a sonar transceiver, so both a receiver and a transmitter, and then it uses automotive chip that cars use actually for detecting distance. But I found that this chip is actually very good. It can also record an echo, and we should be able to get the image of the echo from this chip, and then transfer it to the STM32 and perhaps do some analysis. I mean, this is quite like an open test. You know, I don't know what exactly to expect from this type of sensor, but it's pretty cheap to design, and it's like it could be very useful. We could put it like in water and see if we can get any kind of image from the sonar itself, and see if we can assemble sort of an image of the bottom. So it's going to be really fun. It's going to be fun to see if any of this works. And I think the first step is obviously assembling it. Let's see. So we have components for 4 boards, and I'm going to be assembling them all at the same time, because that's just faster. So I'm going to just put the boards here and take them one at a time. And sort of I'm going to pick a bag from this pile, and I'm going to put on all of the components that are in each bag, and I'm going to dispose of the bag. So let's get started. I'm just going to power on my soldering iron and make sure that I have all the tools. I have some flux here. Where is my soldering? Let's see. Where's my solder? There. So I have some solder here, and I'm gonna be using some working gloves. And I have schematic on the background there. So this is for the sonar sensor, and the other one is, let's see if we can get it up here. For some reason I have really high CPU usage. Come on. So this is the schematic for the long range modem. So this schematic goes on this PCB, this larger one, the green one. And we can also pick out the board. Let's see. I think I need to just open it manually. We can open the board from here for the other one. Oh, this actually opened the board for this one. Okay, so this is the larger green PCB here, the larger one, and the smaller one is also available. Oh, yeah, here it is. It's actually so slow that it takes a while to open a PCB. So this opened that PCB, that's good. And then I need to also open a standalone PCB new in order to get the other PCB. Let's see. I'm just gonna open up all of the PCBs. I have to almost check what is that takes all the CPU. Yeah, so the video encoder really takes a lot of CPU power here. We'll see how the quality is going to be. Hopefully it's going to be good enough. But might as well like skip a lot. I don't know. I'll see when the stream is done. Okay, so let's just pick out the first component here. So the first component is a diode actually. So we can let's see, 1000-volt diode. That should be on this other PCB. Let's see if I can. Oh, this is almost not workable. This is so slow. Come on. I kind of need to get a hang of exactly what would be the best strategy to assemble all of them, because they do have some components in common, but some components only go to one PCB. It would actually be easier to assemble if I had sort of components just for one type of board. That would be a little bit easier, but now I have the components for all the boards in one Mauser order, so it's kind of a little messy to go through one set of boards first and then have to keep the bags and go through the other set of boards and solder them. So I want to sort of find a way to assemble all of them at the same time. I'm just gonna look at the BOM and see if I can have some easy strategy for finding the right spot to solder each component on. So this is the BOM for the radio controller. And we're looking for the diodes here. I think it's, could it be, it's like S1MB13F, but where is that? It's definitely not part of this board, so I'm gonna check the other board. Let's see. Yeah, so this is S1MB13F. Yeah, we can kind of go like this and just sort of try to find the right component based on the let's see, we can make this visible. Yeah, based on the manufacturer part number. So we can start with this diode. Let's just get started. So this is gonna be a diode, actually two of them. So we have two boards, so we're gonna do two of them. And they are gonna go into which spot? Let's see. D2. Okay. This is actually going to be very annoying. So I have to turn this off and then go here. And then find D2. Find D2 like this. I mean, it's a small enough board to be able to see the... Yeah, so this is D1, D2. Yeah. So D2 is right there. So D2 goes there. Let's see. You can put the boards like this. I don't even need a microscope for this. I can just for the fun of it. Microscope is on such high magnification right now that like the diode looks huge. And this is actually going to be a nice test for my custom created footprints. So I created all of these footprints myself with a Python script. So they're supposed to kind of mimic the IPC standard better than the default KiCad footprints. So it's going to be fun. Like maybe something doesn't fit, and we'll see it on the live stream. I really need to get into a workflow right now. I feel like it's going to be a very annoying workflow. Bringing up the BOM every time I need to figure out where the components go. So yeah. Okay. I'll put a little flux on there. It's going to be fun to see how long time this takes. Let's see. Oh, I need to have a muzzle in this. Let's see. Or a nozzle. That would be the correct way to call it. And take the other one. I need to lower the airflow. It's a bit too much. Blowing the components away. So that one's done. Good. Good. Yeah, so then we go to the next component. Let's throw this out. What's next? This is the bag from that one. Let's see. So we got the diode solder there. This was a better soldering job than the other one. The other one is a bit off. It's still sitting on though, but let's get it better. Let's get it to sit straight. And I'm gonna lower the airflow. Yeah. Like, I really don't have to be this perfectionist about it. Yep. Okay. And next on is let's see, 31.6K resistor. Got only two of them, so either it's gonna go on one PCB or on the other. I don't really know yet, but definitely, or probably, like, no, definitely not on both, because we have 4 PCBs, now we have 2, yes, only 2. So, where is this gonna go? 31.6K. Let's see. Everything is so damn slow. So not on radio controller, so it goes on other PCB. Might as well extract the bomb from this one. I can do it later. Let's see. Come on. So where does the cap or the resistor go? Let's see. That's interesting. Didn't have any of these resistors. It's 31.6K. How does that go? 49.9. Nope. Not here. Like, yes, I know there's PCB assembly, but this is kind of therapeutic. Like, this is fun. This is relaxing. Soldering PCBs, soldering prototypes. Okay. I'm gonna skip that one for now. Just go with the next bag. Yeah, actually, there are some bags here from a different order. Some of them don't actually belong to this. Let's see. This is a dip switch. I'm gonna solder that later because it's a lot of plastic. This is a speaker, ultrasonic transmitter. It's also gonna go later. Let's see, what is this? This is 120 ohm resistor. This is for the CAN bus. And we only have 3 of them. Interesting. Damn, this is so damn slow. Come on, zoom in. Come on. Yeah, there we go. There you go. Come on. Yeah. Oh, god damn it. Yep. Come on. Come on. Okay. Come on. This is so annoying. Okay. Okay, so I don't see that one either. I'm gonna put it aside for now. Let's see what else we have. This would be an inductor. MLZ 2012. Not that one. Most probably this goes to another PCB. Yeah, so at least I can find this one. So this would be, let's see, L1 on the radio board. Alright, let's see where L1 is. L1 is maybe I need to check out the PCB, but my computer is so slow right now that if it's faster to just look at the designators, then that'll be the optimal way of doing it. Where's L1? L4, L1. Okay, I'm just gonna look at the PCB. Come on, switch to the next window. Yep. Let's see, where's L1? Find L1. Come on. Like, look how long time it takes to just move this. Find. Yeah. Okay. Oh yeah, that designator was kind of offset, so that's why I couldn't see it. All part of working in KiCad. KiCad is getting really good, but some things are still suffering a bit. One of them is the DRC rules for the things like designators. So L1 goes right there. Let's see, can I put it under the microscope? Where is it? So yeah, there. See, there. That's L1. Yep. So this would be, it's actually easier to like look at it like this, because that will be the same alignment as the image in the background. See? So that will be L1. Yeah. It's kind of a bit slower when doing it like this, but yeah. I'll take that one as well. Okay. I'll take the components and just let's actually do like this. I'll just take all the, put a little bit more flux on all of the pads and just prepare them in one go. Like, so we just have to place components later and solder them. I'm gonna also put my air filter on. It's a nice air filter. Check it out. Let's see. This is an air filter. Yeah. Nice. Can I even talk with the air filter on? It's like, yeah. I need to get a nice fume extractor. That'll be better. I've been looking at fume extractors, but most of the ones I find, they look like knockoffs. They look like they don't really do their job. They look like a joke, all of them. Like with this air filter, I can't smell anything. Like everything is like, the air is clean. I can feel it. I can feel that the air I'm breathing is completely free of any particles. This is nice. The downside is that it's hard to talk with this thing on. Okay, I'm gonna put this inductor is gonna go there. Yeah, so let's see if we can Okay, I'm gonna solder this one, and then on the next one I can put it under the microscope. So yeah, that one is fine, good. And then the next one, I'll get it under the microscope. And under the microscope, all this flux looks like a huge mess. But if you just look at it with naked eye, you don't see any flux almost. It's really nice to have a microscope. So that's where the other inductor is going to go. Let's put it in there. Put it in place. Like this. Come on. Okay. Speed it up. Good. Good. Okay. Nice. Yeah. Good. Yeah, it seems to be on there. That's good. Okay, so moving on to the next component. What's next on the list? Let's see. Get rid of all the garbage. It's next on the list. And then it's some capacitors, electrolytic ones. I mount them last. Let's see, microprocessors. Could be something, but I think I leave it for later. Let's see. So we have. So I want to mount all the components that are less sensitive to heat first, and then I'm going to mount the microprocessors and the electrolytic capacitors and anything that contains lots of plastic that tends to melt. So 603 16 volt 10 microfarad. Where's that gonna go? Got 4 of them. Let's see. 10 microfarad, 16 volts. Where's that gonna go? There. So we got 4 of them, and we have 2 per board. So C25 and C28. Let's see where C25 and C28 is. So I can see C25 right there, and C27, C29, C28 there. So I can see both of them right away on this, in terms of designators, on this board. C28 right there, so we can start with that one. Let's see. So I'm gonna just open up all of them and put them out on my little soldering board. Come on. Yep, so just like that. And getting rid of all the garbage. Like, you really start to appreciate how much these pick and place machines do. I mean, they simplify things so much. You don't have to do this kind of assembly. Like, the reason all of your electronics is so cheap now compared, like, I'm just thinking the same kind of electronics maybe 20 years ago, you know, it's because the pick and place machines do all the work. I want to just sort of prepare all of these first. So I'm going to put as little flux as possible to get the job done. And then I'm going to just prepare all the pads, so I don't have to take out my normal soldering iron at the same time as I'm using my heat gun, just to sort of get the solder on the pads. So just put the solder on the pad first, and then I'll just take out the heat gun and solder. the components. A little bit easier that way. So to the USB connector there. So this modem is actually an STM32 based thing, and it has a so-called LORA modem chip on board, and it has a CAN interface, and it has a USB interface so that you can connect it to the computer. And it is a prototype for that kind of chip. I only found one single chip that sort of had enough documentation and looked like it provided very robust and high bandwidth communication, and also at a reasonable price, that I really had to try this. Like, this is really interesting. How much range are we going to get from this thing? Is it even going to work? Have we even... It's sort of like always the question, like, with the first prototype, when you make the first prototype, it's like, will it even work? Usually it does. Sometimes there is things you notice afterwards that you're like, oh, how stupid could I be that I didn't think about that? Yeah, like putting tampon capacitors backwards. Okay, so just prop it up a little bit. I need to heat the board a little bit, just to get the solder flowing. I just prep it. But you can't even see anything right now, so let's put it under the microscope. And it's really hard to see anything under the microscope as well, if it's so high magnification right now. Okay. But it gets better. It gets better when I start soldering, because then I can just put each component under the microscope while I'm soldering it. Let's see. Like, especially on the ground pad, it's very useful to have the heat gun, because otherwise the moment I move the soldering tip from the ground pad, the solder just hardens, and it becomes hard to put an even coat. A little bit over there. So that's where the dip switch is going to be. So this is going to be a horrible live video of me soldering and you not seeing anything. Let's see. that, come on. Yeah. Once I get a good fume extractor that actually works for my new lab, it's gonna be great. So. The fun part is also going to be programming these things. They're running STM32 Cortex, so it's going to be fun. And it's really fun. I really enjoyed designing a PCB and then programming it. It's really something. So far my new footprints have been working. Let's see how well they work for all the other components. Like even this QFN is generated with my script. So it's gonna be really nice. Yeah. Let's get that. Oh, let's see. Let's just let me show the flux. Just got a little messy. Yeah, that's better. Great. Like without flux, without enough of flux, solder doesn't flow. Let's see. So C28 and which one was it? Like C25, I guess. Or is it C25 and C28? Yeah, C25, C28. Great. So let's put this in there. Oh. Let's see. Gonna make a little bit of better prep for that set of pads. Yeah, cool. See if we can get this under the microscope. Let me get this under the microscope. Let's see. So I can solder it without doing this, but it's just more fun to have it under the microscope. So it ends up on the live stream. Let's see. Where is it? Oh, there it is. Yeah, it's right there. Come on, get in the frame of view. Yeah? There we go. Actually, I'm gonna bring the microscope a little bit higher. Because it's totally unnecessary to have it so low. At least not right now. Let's see. Yeah, that's good. So, great. And then we can just solder this one. Just make it. No, not always. better. So. So now I just move on to the other one. Great. Good. And then we put the C25 on here. Let's see. I have the C25. I have the C25. Okay. It's like I really admire all the people that manage to live stream this kind of stuff. It's like it really requires some planning to get all the cameras set up and keeping all the stuff under the microscope. But it's fun too. It's like it's really fun to put it on a live screen. Let's see, and then we have the last one. And the last one goes on the other PCB. This one. So it's in the same place on the other PCB. So to get this into the tray here though. So come on. There we go. That's better. It's almost like I should have a target for the microscope. Tells me where is the center of the lens. It would be nice to have like some kind of laser pointer or something. I need to have a little bit more of solder on this other pad. It's too little. A little bit of flux. Good. And then we can place the capacitor. Okay. Oh, come on. Good, like that. Excellent. So when it has a good joint, it doesn't fly away anymore because it's kind of sucked into position. Make it a little bit less airflow. Yeah, good. Okay, so moving on to the next. What do we have next on the list? We have the ceramic capacitor, 402 at 1.2 picofarads. That's going to go into the RF stage on this board. Let's see. It's going to go into the RF stage. I think it's going to be somewhere over there. Got it all prepped up. I'm going to just check. 1.2p. That's on the screen. C9, C7 and C9. C7 and C9 is right there, so we can just solder them right away. And these ones are 402s. These ones are really, really small. Not as small as the smallest ones, but still quite small. And I won't be able to solder them without a microscope. That's kind of the point where the microscope becomes an essential tool. Because like even if I solder them without a microscope, the solder joint is likely to be very bad because it's just impossible to see how well they're soldered because they're so small. Let's see. C7 goes there. And C9 goes there. C9. So these two go to ground from the, it's kind of the antenna circuit. Let's see if they blow away. I'm gonna lower the airflow even more so they don't get blown away. Let's just put them into the middle of the screen there. Let's see. There they are, both of them. So it's time to just gently heat them up so that they jump into place. Yep. And then I'm just gonna put a little bit more solder on the pads here. And a little bit more flux as well. And then let's stick them on. So, good. And then I'm going to put them into the view of the, now they're all offset there a little bit. So. Put them in place. And now just heat it up and they will jump in place. that one. There, yeah. Great. Yeah. So that one is in place. And I'm not actually looking at the microscope when I do this. It'll be a little bit annoying to do that. I can kind of see the positioning just by looking at it so closely here. But then I can double check that they're properly aligned by looking in the microscope. Yeah. We'll heat them up later a little bit more when we solder all the components that are around these capacitors. So that one was done. What do we have next? I got some big capacitors. 10 microfarad, 16 volts. It's kind of hard to believe that this is not 603 now. This is 805. So do we have 805 on the other PCB? Let's see. Yeah, so these are 805 actually. Interesting. Where are they? No? Interesting. So I'm gonna leave this bag for now and continue on and then go back to it. So 470 ohms. Where is that? Do we have it in these boards? 470. Yes, here. 402. So there are only two of them. It's R2. Where is R2? Right, so let's buy the diode. This is just a lead resistor. Although we have 4 of them, so... Oh wait. Damn! Look at this. Right. This looks like a really small one. Did I get the wrong article number? Let's just check. So this should be this one. And what do we have on this bag? 147. Yes, I think I got the smallest variant. So this is actually not even gonna be solderable on this board, because they're really small. You can't even see them. Like, you can hardly see them. Let's look at them at the microscope. There they are. They are really tiny. So that was a bill of materials mistake. But that's no problem, because I have a lot of resistors that I can fit in here. Let's see. So let's see which resistor we can fit in here. So I have 120R and 330R. 330R would be the closest one, so I'm going to take that one. And let's see, that would be 603 maybe. I mean, that's almost a little too big. It's the size of the diode, but the resistor here is supposed to be 402. This resistor is 603. So it's kind of on the edge there, but it's still it's gonna fit. I mean, this is not a perfect fit, but for this prototype, it's okay. I'm just gonna note down that I need to change the article number on the resistor so that I can change the package of it. Let's see. Okay, so let's put it on. This way is gonna fit. It's just gonna be kind of not a perfect fit. See? Oh. Yep. The moment it catches on, I just let it be and let it sort of get sucked into place. Yep, that's nice. And then take another one of these resistors, put it on the other PCB. Okay, let's put it in U. There it is. Okay. Let's try to make this one get sucked into place. Like, the big benefit of prepping the board is that you don't really get much smoke beyond that point of actually prepping it with a normal soldering iron. So once it's prepped, it's just matter of heating up the component, and then it just jumps into place. So that one's in place. There is also two more 470R. Let's see if we can figure out where they should be. So, do we have any 470R here? Yes. Let's see. No, this is. Okay. Yeah, so it's R2 actually on every board. So yeah, so R2 on this board is also 470R. No, alright, this is, what am I doing? Let's see, let me just pick off. Let's go there. Yeah, so here, this is the one I'm supposed to be looking at. Let's see. 470R. Yes, we have R11 here. So yeah. So on this little board, it's going to be R11, and it's going to be located. Where is it going to be located? With R10, R11 there. Yeah. So it's located right. It's located right there by D3. So there. Yep. So I'm gonna prep this all of the pads on these boards as well, so I have to do it later. So just putting enough flux on all the pads and then putting some solder on all of them. It's kind of like with all live videos, it's really boring. It's so much dead time in the live videos. So much sort of side work. But on the other hand, you get to kind of see all the steps and even all the fuck-ups. Like, this is not even meant to like teach you how to do it. This is just the way I do it. It's kind of fun to take a PCB from design to full manufacture and kind of do it yourself. It's nice. And it's kind of like anybody can do this. It's not that hard. Like, it's possible. What I mean is that it's possible to do all of this stuff without needing to have like really expensive pick and place machines that are used in mass manufacture. And I can understand perfectly well that somebody who's sort of not manufacturing thousands upon thousands of PCBs every day is probably not going to have a pick and place machine, because that's when pick and place machines actually start being very good investment. But like obviously we can order assembly as well, so it's not like it's automatic assembly is not completely off limits. It's just that it's interesting to also know that it's possible to do this process oneself without needing to order assembly. And especially like for small batches, just to get something evaluated. Like PCBs are really cheap. Assembly is a little bit more of an investment. So I could definitely see it like it's good money for time. Like this does take time. I mean, this is not something that is really quick process. But for small batches, it's actually quite fun to just do it yourself. And also you get to, like, it's kind of like you always have to know how to do this, because if something doesn't work even on your factory assembled board, then you have to change it yourself. Like you still have to do soldering yourself, because then it's just, if you can't do repairs on factory assembled boards, then it's really gets really expensive. If you have to send it over to someone to do like a replacement of the components, it's nice to be able to do this. Like you don't have to assemble the boards manually, unless you're like me. So you just put some solder on all the pads, just a little bit, not much, just enough to keep a component stuck to them.